students to standard 9th maths chapter 9 areas of parallelograms and triangles, and we are in the 4th session. Children, in previous session we learned what are two figures on the same base and between the same parallel lines. Alright, two quadrilaterals, two triangles, triangle and quadrilateral. Alright, based on that we are going to see what first theorem 9.1, parallelograms on the same base, parallelograms on the same base and between the same parallels are equal in area. So children, let me draw the figure. Correct, children? All right. Here are two parallel lines. All right, L and M. And I'll choose one base. This is one parallelogram, AB, CD. The base is AB and it lies between the two parallel lines L and M. Alright, another parallelogram. I'm going to keep the base same. And parallelogram different. A, B, E, F. Alright. So children, parallelograms, the blue one and the red one, on the same base, AB, and between the same parallel lines L and M, are equal in area. That is what you are supposed to prove. Alright, data. Parallelogram ABCD and parallelogram ABEF lie on same base AB and between L parallel to M, or between AB parallel to CD, FE, whatever you want you can call. To prove area of ABCD is equal to area of ABEF. That is parallelogram ABEF. Is that clear? Now children, how will you find that? Please, I am going to show these two triangles are congruent. Triangle ADF and triangle BCE. Alright? Children, these two are parallel lines because this red quadrilateral is a parallelogram. So this angle are corresponding angles. They are equal. Same way, these blue lines are parallel because they are opposite sides of blue quadrilateral. So these angles are equal. Once again, corresponding pairs of angles. And the red side AF is equal to red side BE. So angle side condition is satisfied. Is that clear? So the two triangles are congruent, and if the two triangles are congruent, that means they are overlapping. They are coinciding, so they always have equal area. Alright, so area of this triangle and area of this triangle are equal. Then we'll see what we do next. Okay. Proof. Alright, the red one. Okay. Straight away we'll write. In triangle ADF and triangle BCE, angle AFD is equal to angle BEC corresponding angles. Alright? Corresponding angles. We are writing directly. Similarly, angle ADF equal to angle BCE. These are also corresponding angles. Alright? And then AF actually is equal to BE. Opposite sides of parallelogram. That is the reason why they are equal. Alright, children? Okay. Now, therefore, a correspondence. Which one? हम AFD लिख देते हैं. AFD corresponds to dash is congruence by angle side congruence rule. Angle side. Now बीच में देखो F corresponds to E. F middle में, so यहाँ भी E middle में आएगा. Then D corresponds to C. D is last, so C last. So that means A corresponds to B. A corresponds to B. Therefore, what you got? Therefore, बोलिए children, triangles are congruent. Triangle AFD is congruent to triangle BEC. Therefore, area of AFD is equal to area of BEC. Result 1. Alright? Okay? So, these triangles are having equal area. That is what we proved. Alright, children. Now, let me pick up the area of this. Alright? Parallelogram ABCD. That is the blue one. Now, area of ABCD is equal to, children, if you look at the blue one, you will find this quadrilateral and triangle. The blue parallelogram is divided into two parts. This is quadrilateral and this is triangle. So area of, yes, ABED plus area of the triangle, yes, BEC. But area of triangle BEC same as AFD. So I'm going to use that. Therefore, area of ABED plus, children, instead of BEC, I'm going to write area of AFD. Now look into the figure now. Yes, this part remains the same, ABED. But if you add this area of triangle here, then it becomes area of the red triangle. So ये दोनों का total area of red triangle and area of red quadrilateral, and that is parallelogram ABEF. ABEF. That's it. Therefore, area of ABCD is equal to area of ABEF. Proved. Is that clear, children? Okay. Fine. Alright. Now, children, there is another way of proving it. I'm going to show you this as well. This is what is given in your textbook. Alright. What is the next way of proving it? Let's see. All right, children. See, from this E, I'm going to drop altitude EM. Proof. And then I'll find out the area of blue. Okay, since this is of blue, yeah, of course, this is of red one, you can say. The vertex is E, so this is altitude of red one. Same way, from vertex D, if I drop another perpendicular to the base AB, then that is DN. Alright? Why I have dropped perpendiculars? They are altitudes. Then what is the formula to find area of parallelogram? Yes, base into corresponding altitude. So first I'll find out the area of parallelogram ABCD. Then I'll find out the area of parallelogram ABEF. Alright? Then we have to show that their areas are equal. That means their ratio will be 1. Area of parallelogram ABCD upon area of parallelogram ABEF is equal to 1. That ratio is 1. That is what you will have to prove. So we can use Euclid's property. Let's see. First we find out the area of parallelogram ABCD. ABCD is the blue one and its corresponding altitude to base AB is DN. Alright. Let DN be perpendicular to AB and A dash and dash B. Therefore, area of parallelogram ABCD is base into corresponding altitude. Base is AB into altitude is DN. Call it result 1. Alright, children. Next is what? EM be perpendicular to, yes, AB and A dash M dash B. A dash M dash B. Therefore, area of the red one now, ABEF. Area of parallelogram ABEF is equal to base, that is AB, into corresponding altitude. What is the altitude of red one? That is EM. Call it result number 2. Now take the ratio. By 1 and 2, it follows that I'm taking this left hand side, area of ABCD upon left hand side, area of ABEF is equal to right hand side, AB into DN upon right hand side, AB into EM. AB cancels. Children, we were expecting this ratio to be 1. लेकिन मुझे तो DN upon EM आया. Now call this as result 3 because we have not reached the goal yet. Correct, children? So now look at DN and EM. DN is the blue segment, EM is the red segment. Oh children, they are perpendicular to the same line. So they are parallel. And L is parallel to M. So DE is parallel to MN. Now ये pair of opposite side parallel, ये pair of opposite side parallel. So it is a parallelogram. और उसमें one angle, right angle. So it's a rectangle. So you will have DN equal to EM. This DN equal to EM. Alright, children एक बार फिर लिखते हैं, फिर result 3 कहते हैं क्योंकि यहाँ cancel किया है. Area of ABCD upon area of ABEF is equal to DN upon EM. Call it result 3. Alright. Now I am writing that big statement. कौन सा quadrilateral? NMED. In quadrilateral NMED, both pairs of opposite sides are parallel. And children, DE is parallel to NM because L is parallel to M. And DN is parallel to EM because they are perpendicular to the same line. And one of its angle is right angle and one of its angles is a right angle. Therefore, quadrilateral NMED is a rectangle by definition. Therefore, dn is equal to em. Result 4. dn की जगह पे ये dn को निकालो, and in that place you write em. Correct? So by 3 and 4 we are going to use two results. By 3 and 4 it follows that. Alright, area of parallelogram ABCD upon area of parallelogram ABEF is equal to dn. But in place of dn we are going to write em upon em. So that cancels. So that is equal to 1. Therefore, इसको वहां ले जाओ. So area of parallelogram ABCD is equal to area of parallelogram ABEF. Proved. Did you understand, children? Sure. So that was another method. All right. Now moving on to another theorem, and that is theorem 9.2. Let us see the statement. And here is the statement, children. Two triangles on same base or equal bases and between same parallels are equal in area. Children, what we saw in theorem 9.1, two parallelograms, and here in 9.2, two triangles. I have already drawn the figure. Base AB of black triangle and base again same AB of red triangle as well. Alright, children? Okay, so we have red triangle and black triangle on same base AB and parallel lines L and M. So that is same bases. Or children, you can have equal bases. Equal bases means what, children? You may have another triangle जिसका base equal हो. Suppose that here it is PQ और यहाँ R. तो ये triangle PQR, ये दोनों ट्राइंगल अलग है, लेकिन AB इक्वल टू PQ. तो B black triangle will have equal area to green triangle. Okay, अब इसका हम प्रूव नहीं करेंगे, इसका ही सिर्फ प्रूव कर रहे हैं हम लोग. Alright, you can prove that very easily. Okay, now see data. Triangle ABC and triangle ABD lie on same base AB and between, yes, L parallel to M. Correct? To prove area of triangle ABC is equal to area of triangle ABD. Area of red and black are equal. That is what you have to prove. Let's see. Proof. Children, once again I target to find area of triangle ABC, then find area of triangle ABD, and then take their ratios, which should be equal to 1. By using Euclid's property, you can take the ratio. Now, what is the formula to find area of triangle? Half into base into corresponding altitude. So ABD, ABC, the black one, C से मैं altitude drop करता हूं. Let's say that is CM. So let CM be perpendicular to AB and A dash M dash B. A dash M dash B. Therefore, area of triangle ABC is equal to half into base, that is AB, into corresponding altitude, that is CM. Call it result 1. Alright, children. Same way, let's find. Okay, next triangle is red one. From D, I drop perpendicular, and let's say this is DN. Alright, वो उसका altitude बाहर होगा. Let DN be perpendicular to AB. AB कह सकते हो, L कह सकते हो, whatever. And N dash A dash B. N is outside, foot of perpendicular. N dash A dash B N dash A dash B. Therefore, area of triangle कौन सा ABD? ABD is half into base. Base is AB, children, and altitude is DN. Result 2. Children, आपको ये triangle का area मिल गया, फिर ये triangle का area मिल गया. So take the ratio. So by 1 and 2, it follows that area of triangle ABC upon, ratio means upon, area of triangle ABD is equal to, right hand side पे, yes, half into AB into CM upon half into AB into DN. AB cancel, half cancel. Therefore, area of triangle ABC upon area of triangle ABD is equal to CM upon DN. Children, we were expecting this result to be 1 on right hand side, but I didn't get. So I'll just stop here and call it result number 3. Once again, ये CM or DN, they should be equal. Now look here, CM is this, DN is this. Alright, quadrilateral NMCD. Yes, NM is parallel to CD because line L and M are parallel. And DN and CM, they are also parallel because they are perpendicular to the same line M. So, and one of the angle is right angle. So, it's a rectangle. So, DN is equal to CM. That is what we get. So, I'll write in quadrilateral NMCD, both pairs of opposite sides are parallel and one of its angles is a right angle. Therefore, quadrilateral NMCD is a rectangle. Therefore, opposite sides DN is equal to CM. Call it result 4. ये CM की जगह पे आप DN लिख दो in result 3. So by 3 and 4, it follows that yes, area of triangle ABC upon area of triangle ABD is equal to, in place of CM you are going to write DN. So DN upon DN will cancel, okay, equal to 1. Therefore, area of triangle ABC is equal to, ये वहां गया, area of triangle ABD. Proved. Is that clear, children? I hope you have understood. Alright. Children, theorem 9.3 is converse of this. Oh children, I just erased. If you want to show black equal to green, तो आप ग्रीन का अल्टीट्यूड ड्रॉप कर लीजिए. सो हाफ इंटू बेस इंटू अल्टीट्यूड, हाफ इंटू बेस इंटू अल्टीट्यूड. नाउ ये अल्टीट्यूड देखो इधर रेक्टेंगल फॉर्म होगा. सो दिस इक्वल टू दिस और ए बी इक्वल टू पी क्यू. इसका एरिया क्या आएगा चिल्ड्रन? यहां क्या आएगा? एरिया ऑफ दिस ट्रायंगल इट इज गोइंग टू रिमेन द सेम. लेकिन ये एरिया ऑफ ट्रायंगल पीक्यूआर, यहां PQR होगा. PQR is equal to half into base, that is PQ, into altitude, that is R, let's say RK. Alright, so RK. Now half cancel and AB and PQ also will cancel because they are equal. Bases are equal. So once again CM upon RK. So RK and CM are equal in that rectangle. So CM की जगह पे RK लिख देंगे तो वो भी कैंसल. So that is equal to 1. So area of triangle ABC is equal to area of triangle PQR. I hope you have understood that, children. You don't have to write for this. You have to write only for this. I have just explained to you. Is that clear? Alright. Now theorem 9.3, it is converse of 9.2. 9.2 says if two triangles on the same base and between the same parallels are given, then they are having equal area. Now, if two triangles on the same base have equal area, then they will lie on the same parallels or between the same parallels. Alright, that is the statement of theorem 9.3. We are not going to prove it, children. We shall not prove. I am just writing the statement on the board. Alright. What is the statement of theorem 9.3? Two triangles on same base and with equal areas lie between the same parallels. Children, here is one triangle ABC. There is another triangle BCD. They lie on the same base and area of both these two triangles are equal. Then definitely they lie between the two parallel lines BC and AD. That is what the statement says. Theorem 9.3. We are not going to prove it. Alright, children. We are going to see the examples, illustration. So example number 1. I just write down the statement. And here is the statement, children. In figure below, ABCD is a parallelogram. That black quadrilateral that you see is a parallelogram. And EFCD, that's a rectangle. Yes, I'll have to show one of the angle, right angle, to show it's a rectangle. Alright, children? Okay. Also, AL is perpendicular to DC. Yes, blue segment AL is perpendicular to DC. Prove that area of ABCD, which is a parallelogram, and area of EFCD, which is rectangle, are equal. Oh children, theorem 9.1. See, the red quadrilateral is on base CD and the black quadrilateral is also on the same base. So both quadrilaterals are on the same base, but black one is parallelogram, but red one is not. We should have two parallelograms. But children, every rectangle is a parallelogram. So red one is parallelogram, black one is parallelogram. So we have two parallelograms on the same base CD and between the same parallel lines. Alright? Here L and M is not given, but I'll write in the figure. Those two parallel lines are L and M. Okay? So that means their areas are equal. So first one is proved. Next one we'll see what to do. But first, let's prove the first one. Data, I'm not writing. To prove, I'm not writing. I'll start with proof straight away. Okay, children. Quadrilateral, which one? EFCD. EFCD is a rectangle by data. Therefore, quadrilateral EFCD is a parallelogram. A parallelogram. Call it 1 by property. By property. Or quadrilateral black one ABCD. ABCD is a parallelogram. Call it result 2 by data. So by 1 and 2 it follows that both are parallelograms on the same base and between the same parallels. By 1 and 2 it follows that quadrilateral EFCD and quadrilateral ABCD are parallelograms on same base CD or DC and between same parallels. Therefore, area of, yes, ABCD is equal to area of, what is that? EFCD. Proved by Theorem 9.1. Correct? So first result is proved. Now second, children, area of ABCD, which is parallelogram. Correct? Area of ABCD is parallelogram. We have to prove that is DC into AL. Now what is DC here? And what is AL? Yes, that is there. Area of parallelogram. DC is base and AL is altitude. Alright. By definition. Alright. Just check. Yeah, it is ABCD only. Okay. Now, AL is perpendicular to DC by data, and area of parallelogram ABCD is base into corresponding altitude. Now the base is DC and altitude is AL. Finished. Proved. i.e. area of ABCD is DC into AL. Proved. By definition, children, ये definition ये है. Proved. Proved second, and here you may write proved first. Is that clear, children? Alright. Next is example number 2, which will be the last for this session. Alright. Let me write the statement. And children, here is the statement. Children, this is not only example, very important result we'll be using. This is as good as theorem. Alright? See what it is given. If a triangle and a parallelogram. In Theorem 9.1 we had 2 parallelograms. In Theorem 9.2 we had 2 triangles. But in this example we have triangle and a parallelogram. They are lying on the same base AB and between the same parallel lines L and M. Is that clear? So a triangle and a parallelogram on same base, lie on same base and between same parallels. Then area of triangle, the red one, is half the area of parallelogram, black one. Children, what shall we do? Okay. Data, I'll write this time. Quadrilateral parallelogram ABCD and triangle ABE lie on same base AB and between same parallels L parallel to M. That's it. To prove area of triangle, that is ABE red one, is half the area of parallelogram, the black one, ABCD. Proof. Children, once again we use the same trick. Let's find out area of triangle ABE first. पहले इसका area ढूंढो. So what is the formula to find area of triangle? Half into base into altitude. So triangle का मैं altitude ले लेता हूं, तो ऐसे बाहर आएगा EM. Let EM be perpendicular to AB and M dash A dash B. M dash A dash B. Therefore, area of triangle ABE, no need to write triangle, right? ABE is equal to half into base, उसका AB है, और altitude is EM. Call it result number 1. उसके बाद I want area of this ABCD. So I'm going to take altitude. From D I'll take DN is perpendicular. Correct? Let DN be perpendicular to AB and A dash and dash B. A dash and dash B. Therefore, area of parallelogram ABCD, उसमें हाफ नहीं आएगा, ओनली बेस इनटू कॉरस्पॉन्डिंग अल्टीट्यूड. बेस AB है और अल्टीट्यूड DN है, रिजल्ट 2. बस रेशियो ले लीजिए. बाय 1 and 2 it follows that लेफ्ट हैंड साइड पे एरिया ऑफ ट्राइंगल ABE है, सो एरिया ऑफ ट्राइंगल ABE अपॉन लेफ्ट हैंड साइड पे एरिया ऑफ पैरेललोग्राम ABCD है, सो ABCD इज इक्वल टू राइट हैंड साइड पे हाफ इंटू AB इंटू EM है, होल अपॉन यहां AB इंटू DN है, AB इंटू DN. वेल AB कैंसल्स. नाउ दिस 1 अपॉन 2, 1 ऊपर रहेगा और 2 नीचे आएगा, सो EM अपॉन 2 टाइम्स DN. काम अटक गया हमारा. दिस ऑलराइट. नाउ इफ यू लुक एट EM and DN, EM is this and DN is this, so quadrilateral M and DE, it's a rectangle, हम प्रूव कर चुके हैं. So in quadrilateral M and DE, both pairs of opposite sides are parallel and one of its angles is a right angle. Therefore, quadrilateral M and DE is a rectangle. Therefore, ME equal to DN या EM equal to DN. Call it result number 4. Thus, by 3 and 4, it follows that yes, area of triangle ABE upon area of triangle, actually quadrilateral parallelogram ABCD is equal to क्या है EM, but in place of EM I am going to write DN upon 2 times DN. DN cancel, so आपको हाफ मिला. क्रॉस मल्टीप्लिकेशन करिए, सो वहां गया. Therefore, area of triangle ABE is equal to 1 upon 2 तो रहा ही, और ये नीचे से वो साइड एरिया ऑफ पैरेललोग्राम ABCD. Proved, children. That's all. All right, children. I hope you understood this session well. See you in the next session. Till then, goodbye. Have a nice day, children.